Hello students, my name is Ajitesh Moy Ghosh. I am Assistant Professor of Computer Science and Engineering Department of Adamas University. Today we are going to talk about some other data structure of C++ and it is the lecture 2 of module 2. Today's topic we will cover queue, double-ended stack and queue, then time complexity, which is very important to know that how much time it is taking the particular program, the stack program or queue program or any other. Then tree, which is also a very important part, which is actually the non-linear data structure, and heap. Heap is also very important, and we will talk about little bit about in order, pre-order and post order. Now queue is a linear data structure where the operation is performed from both the ends. That means one end will insert element and other end will delete element, or elements will be coming out from that end. So if we consider a queue, the first position will come out first and sequentially it will move on, then the second, then the third, like this. So when we insert an element into the queue, we use enqueue function. We call it enqueue, that is enter into the queue. And when an element is deleted from the queue, we use dequeue function, that is deletion from the queue. So when we talk about the queue, we follow the first in, first out. That means the first position will come out of the queue at first, then sequentially other elements will come out as per their order. We can implement this queue using structure, and we can also implement some other method also with the help of C++. Now this particular example is showing that elements which are present in the queue already there, that are 3, 4, 5, 6, 7, 8, and 9 is going to be inserted, and the first element 2 is coming out, that is dequeue, and the 9th element is enqueue. Double-ended stack linked list is a very important concept. That means from both the ends, both the ends, both the operations can be performed. We have seen in our previous module, lecture 1, module 2, that stack operation can only be performed from a single side. That means push and pop can be performed from one side. It cannot be performed from both the sides. Here we can see this push and pop is being performed from both the sides. So that is double-ended stack we are talking about. So it can also be implemented using C++ or even with the help of C. Now, linked list is another linear data structure, which is a very important concept in case of implementing so much things. Like even we talk about certain high-end programmings as well, it can also be performed with the help of linked list. Here in the picture, we can see a particular rectangle is divided into 3 parts. Now here you have to understand, students, the first part is holding the address of the last part. You can see from here the next part address is being considered, and the last means third part is holding the address of the second rectangle, and the middle part holds the value which we want to store. So there are 2 address parts and 1 value part. We can have linked list having 1 address part and 1 value part. So this is very important to understand. To implement the double-ended linked list, we have to consider 2 address parts, or if we want to implement singular linked list, then we need to have only 1 address part. So when we have only 1 address part, the last position where next is present now, it will hold the value called null, in caps NULL, null. That means the last address part is not holding anything in case of singular linked list. Simultaneously, if we talk about the double linked list, the last address part is stored to the first address part of the first node. Here each rectangular part is called a node. So we can create n number of nodes as per our requirement. So I hope you are able to understand the concept of double-ended stack, double-ended linked list. Also we can implement double-ended queue. Here double-ended queue, when we talk about, we have seen in the queue that NQ is performed from a side and DQ is performed from another side. Now we can perform both NQ and DQ from both the sides. That is double-ended queue. Okay. This is perhaps the most important concept to know, the time complexity by which when programmer try to implement any program, they keep their concept very clear in their mind that which particular data structure consider how much time. Otherwise the program will execute slowly and the time complexity will be more. Here we have mentioned that array is a data structure. The average time, access time is O1, theta 1, that is average, and theta 1 means it is the access time, the search time is theta n, insertion time is again theta n, deletion time is theta n. So like this, and for the worst case it can have on for the search, for the access it can have o1, for the insertion deletion also it can have on. Similarly, we can see for the stack there are time complexity present for the average and the worst case both. Here if omega we mention, that is the best case, but we have considered here average and the worst case. Now for the queue as well we can have the time complexity of average and worst, and singly linked list, what we have just discussed in the previous slide. Singly linked list means only one address position and one value position in a single node, and the last node address position will contain NULL, null. Double linked list we have just discussed in the previous slide. It has the time complexity of this, and binary search tree we will discuss in the coming slide. Okay. Tree is a very important concept in the data structure because it represents the nonlinear data structure. And when we talk about the binary tree, that means a single node can have maximum 2 elements, and a binary tree also can have a single child node of a root, then it will not be called as a complete or full binary tree. Complete or full binary tree means when we have child, when we have both the childs in the root node, with the root node. So from these two pictures you can very well understand that full tree is considered on the left and complete tree. Now what is actually the difference is, when we see the complete tree we can see very well the left child is completed, left node is completed. That means we do not have any incomplete root node on the left where we do not have any child. But in the case of full tree, the left node is blank. So when we call a complete binary tree, we will look into the part where left node is completed. Okay. And heap It is very important concept. It is tree based data structure that satisfies the property of the heap. Here we can see two pictures will explain two concepts. One, if we consider the first one on the left, here you can see the root node, that is 100, 19, 36, 17, all these nodes are having greater value than their child nodes. So this concept called the max heap means when the root node value is always greater than the child node. On the other hand, if we consider the second picture, we can see the root node, that is 13, 21, 24, 31, 60, all these values are lesser than the child node. So that is the mean heap. So max heap and mean heap, these are the two concepts of the heap. So we have to be very careful while selecting the max heap or mean heap by considering the value of the root compared to the children. It is also very important concept, in order, pre-order and post-order. Actually, this concept is very much required when we traverse a tree to find a value. That is very important, we have to know this. Now here we can see the two information is depicted. One is breadth first search and another is depth first search. Now why depth first search? Let us consider this one first. That is, actually you can see, if we follow the arrow, the traverse started from the root, that is the value having 1, then it traversed to the child, left child first, that is value having 2, then it will traverse to the left side of the node 2, then it will traverse to the right node of node 2, then again it will traverse to the right node of the node of root 1. This is how it is traversed. Now when we talk about the pre-order traversal, you can see the root node is placed at the first position, then it is traversed the second left child node 2, then the left child node of 2, 3, then the right child node of 2, 4, then the right child node of root 1, that is 5. So always understand, in case of pre-order traversal, it is very important to know that which will be the root node, that is the first element which we mentioned. If it is in pre-order traversal or pre-order, mentioned pre-order, the first element must be the root. So how it is traversing? Root, left, and then left if there is any other further child, then right, right. In case of in-order traversal, we can see that it is started from node 3, that is the leaf node we are talking about, 3, leaf node means where we do not have any further node, where the child nodes are not present, that is the leaf node. So in case of in-order traversal, 3 is first traversed and then 2. That means in-order traversal will happen left, then root, then right. You can see 3, 2, 4, left, root, right. Then again it will traverse, as because it is traverse the left, it will traverse to the root node 1, then again it will traverse to the 5. So in order traversal like this, left, root, right. Post order traversal, which is also very important to know, 3, it will first traverse the left node and then it will traverse to the right node, then it will traverse to the root node. So 3 traverse first, then 4, then 2, then again 5 will be traversed after 4, then 1. So in case of post order, the last element must be the root element, and in case of pre-order, the first element must be the root element. And breadth first traversal traverse level wise. That means when first level is completed, then the second level will be completed, then the third level will be completed. Like this it will be traversed. So in case of breadth first search, the traversal will be 1, 2, then 3, then 4, then 5. So it is the breadth first level by level, and depth first search path through leaf. It is very important to know the recursion follows the depth first search, and it follows from the leaf node, it will go up to the root node. And when we talk about the binary search tree, it is very important to know that binary tree must have 2 nodes, then it will called a complete binary tree. That means the left node has to be fulfilled first, otherwise it will be not a complete. Now you can see from here in order, pre-order, post-order, what we have just discussed in the previous slide, that in order is left, root, right. Left, root, right. So left is D is the leftmost, it will be traversed, then root B, then right, as because rightmost element is H. You can see rightmost element of B is H. So H will be traversed, then the root of H is E, will be traversed, then the I will be traversed, then the root A will be traversed, then the rightmost of A is F. Rightmost of node of A is F. So F will be traversed, then the root node will be traversed C, then the G. So like this it will be traversed. And pre-order always root node will be traversed first, that is A, B, D, then E, H, I, then C, F, G. So you can see from here, pre-order, the first element always be the root element, and the post-order left, right, root. You can see the leftmost element is of the tree is D and the rightmost element you can see of the D is H. So DH, then right element I, then root E, then root B, then the right traversal means F will be traversed, then G will be traversed, then C will be traversed, then A. So it is A, the root node will be placed at the last in post order. So students, we have discussed some very important concepts as far as programming and data structure is concerned. We have discussed queue, we have discussed double-ended stack, linked list, double-ended queue we have also discussed, then binary tree, tree traversal, in order, pre-order, post-order we have discussed, then heap, also very important concept in stack we also have discussed. Now the implementation part, I hope all of you will go through this and will try to implement using the particular programming language. You can choose C++ as well, you can choose C as well. So if you have any particular query related to programming and data structure, you can please connect me with the email ID given below. Thank you.